Hello friends, I am Saroj Vishwas, gold medalist, first rank holder of 1994 batch in engineering stream of all the colleges affiliated to University of Mysore during that period. A BE in civil engineering from National Institute of Engineering Mysore, a MTech in structural engineering from Indian Institute of Technology, Delhi, that is IIT Delhi, a Sun certified Java programmer, Sun Microsystem USA. I have more than 25 years of professional experience in designing building structures and allied subsidiaries. I invite you all to learn with me how to design building structures using commercially available structural softwares with the help of some manual computation as and when needed. In this section, we shall make the data in longitudinal direction, that is this direction, that can be used by the structural detailer to prepare the structural GA. So let us cut a section. Shift N, Shift S will hide the support, Shift plus N. So grid number 1, the section along 1 and 16 are similar. So we will have same data along this direction, and along grid 15 it will be different. So if you go back to our structural GA, not a structural GA, if you see our grid configuration, then we can see these are the grids. Grid 1 and 3 are similar, but grid 2 is different. So we'll have a cross-sectional elevation along grid 1 and 3 with a note along grid 3 there is a landing beam between grid A and B. Let us cut section along grid 1. Tool, cut section, YZ, grid 1. So this is our section. So Shift 10 will hide the node number. Now let us go to label, structure, section outline. You can see this is the section. So using snipping tool, I cut this section, edit, copy, then go to the Excel file which we have been using. Now let us paste it here, paste. So this is our cross section along grid 1 and 3. Now let us go to the start file again. Let us open the property. So the top members are SHS 91.91.5. Then again nominal bore of 1. It top is R3, so nominal pipe of nominal bore 80 mm. So if you go to the start file, this is our grid A, B, C, D. Now let us put the grid line as well here. Go to insert, shape, let us take a line. So putting this will help the draftman not to be confused. Format, shape outline, dashed line, black, weight. See this. Now let us put the grid mark here. This is A. Home. Let us make it black. A. Format. Shape fill. No fill. Shape outline black. So this is our grid A. Similarly, we should provide the grid at other places also. Note that in transverse direction, at this direction I did not provide the grids. We may provide it, but it was actually not required because this part in transverse direction, the structure is symmetrical about its both halves are symmetrical, so structurally symmetrical about grid 2. But if you go to the longitudinal cross-section, it is not the both halves, left hand half and the right hand half are not symmetrical. So for in this case, we should supply the grid number as well. Now this is our SHS 91.5 into 91.5 into 3.6. So similarly, we should provide the data for other place also. So this will be our data along grid 1 and 3. We may provide the column sizes as well, but it is actually not required because the column sizes are already given in transverse direction. So all columns are already covered in transverse direction, so the detailer could find it from there. In fact, at times in structural GE also, these sizes are not provided. The fabrication drawing detailer retreats from the other directions. Next is to provide the connection detail. So reading the connection detail, we will have this kind of connection detail. The frame cross-sectional elevation with the connection details. Now if you see, this is it. LP1 is having nominal bore of 80 mm medium pipe. LP2 is having square hollow section. Clip-on is the beam connection, and at detail C, if you notice at detail C, I'm just zooming it out, there is the flange plate is not continuing to the end plate. This is to just simulate pin behavior as far as possible. So only the wave plate is extended to the end plate, and there is a gap created, and for the beam on the other side also, the flange plate is stopped before it reaches the end plates. So this type of detailing has to be kept in mind when we desire the connection should not develop any movement. This is our detail B. So this kind of connection is suitable when it is required that as far as possible bolted structure should be there and column should be as far as possible free of gusset plate. But if you think a little bit, if you consider this end plates, these are the end plates, you can read the end plates and the bolts are with the end plates. So if you, instead of providing these end plates, we can directly weld this gusset to the web of the column, and we can provide some stiffener here in the beam itself, and here we can provide a simple connection. So similarly here also, instead of these end plates or these end plates, we can directly weld this gusset, and we can provide a stiffener plate here, so that it further strengthens the web of the column, and which will actually produce a simpler detailer. So if we want to have a simpler detailer, we should actually think of providing a gusset plate welded to the web of the column with stiffener plates on the other side to provide adequate strength to the web plate of the column, because web plates are very thin. So this is our now having detailed all the details along grid 1 and 3. We know there is slight difference between grid 1 and 3. There is a landing beam between A and B. So just we copy pasting it and drawing that, taking this from the Excel file itself or copy pasting it and adding a beam at mid level, we can have the grid cross section along grid 3. So we will make this cross section along grid 1 and copy pasting it, we will have this kind of elevation along grid 3. This will be our elevation along grid 3. So we have added this landing beam. You can see this landing beam here. This is the landing beam along grid 3, which is supporting the stringer of the staircase at mid landing level. Next, we have taken the cross section along grid 2. So we are going to draw the I-beams wherever it is there. Insert, shape, there is the I-beam here. There is another I-beam here. Paste. This column is actually below the I-beam as a pin connection. We have already shown this in transverse detail of the frame. So we have copy paste on I-beam here, I-beam here, I-beam here. These are the rafters which are at the roof level. Now here the end plate is connecting at the end, so we can use LP1 same as ELP1. Copy. Let us copy this. Control C. Paste. So this will be our let us check the properties. They are all nominal bore of 80 mm dia. So pipe, copy, paste, paste. Now let us see what is the connection. You can see these are all simple connection. So it will again have the clip connection. So let us copy this, copy, paste, clip on. So this is our copy, paste, ELP1. This will be ELP1. For this, will provide a remark. Control C, paste, refer to roof detail. So this connection details will be detailed at pressing, because there are 3 members which will be connected here. Again here also the same thing, 3 members which is going to be connected here. So this detail will provide, when we will provide the detail of the GA at the roof level, so that will provide a better clarity, because there are 3 members at these positions. 3 members are coming. So accordingly we have to provide the detail. So roof plan detail for the GA will provide detail here. Detail for the same. We have an plate here, that is ELP1. Now these are all clip connections. So let us make those clip connections. We have already had some clip connections here. 1, just take a step. There is a clip here. Just fill it with some different colors so that it is visible. Paste. Just somewhere paste. This is our clip. Paste. 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 So these are all clip on, all are clip on. let us write it. Clip on, clip on, clip on, clip on. So we have the cross section along grid 1, the cross section along grid 3, and the cross section along grid 2. See, the grid marks has to be marked here so that it will come to know where is there is meridional level beam or where it is not there. With this, we complete the structural GA detail along longitudinal direction. In next section, we shall cover the mezzanine floor plan and the roof plan, and that will complete our GA data required for a structural GA detailer to prepare a structural GA. Along with this, we have to put certain more information to him, like if there is some brick wall at plinth level, or what is the spacing of guards and purlins, that we can provide in the form of a notes to him. According to that, we will prepare the GA. And we need to have a architectural elevations also where the openings, so that the detailer assumes the detailer provides required cuts and details or purlin details according to the opening in the roof, if any, in the form of skylight or opening light doors or roller shutter at all elevations.